Dear students, in our previous class we have derived Newton's forward difference interpolation formula. And Newton's forward difference formula, when we have derived, we have used the operator, shift operator and forward difference operator. And also we have discussed the numericals that where we will use it. Today we will discuss the related topics, that is Newton's backward difference interpolation formula. We will derive the formula and we will work out the numericals to clarify your doubts. Okay, so let us start. Newton's backward difference, Newton's backward difference interpolation. Okay, so you see how we derive. Like the previous case, here also we will have the data. So let x0, y0, x1, y1 up to xn, yn be set of data, and xn is equal to x0 plus nh. That means it is equispaced because the nth data xn we found by x0 plus nh, means h is the step length, and n is number of steps. Okay, so this is the data what we are given. Now we have to derive the formula. So let the desired point x, because we have to find the value of y at x, so we redefine the step length as x is equal to xn plus ph. Previously the step was defined as xn equal to x0 plus nh. As per our requirement x, we define x is equal to xn plus ph, means the step length is changed. As step length is changed, so number of steps will be changed. So we define x is equal to xn plus ph. We arrive at the ph steps, that is yp. Yp is equal to f of xn plus ph. Okay, but f of xn plus ph, that can be written as shift operator, that is e to the power p f of xn, and this f of xn can be rewritten as e to the power p y of n. We know the relationship between the backward operator and shift operator. The relation is, you know, that is e to the power minus 1 is equal to 1 minus backward delta, right? So you can write it as e to the power minus 1 to the power minus p is equal to 1 minus backward delta to the power minus p. That gives e to the power p is equal to 1 minus backward delta to the power minus p. So in place of p, we put these values, that is 1 minus backward delta to the power minus p yn. Then expanding this as per the binomial theorem, we get, that is 1 plus p backward delta yn plus p into p plus 1 by 2 factorial backward delta square yn plus p into p plus 1 into p plus 2 by 3 factorial backward delta q yn, and so on. So this is the formula of our Newton's backward interpolation. Just how to remember, in forward difference, here we are using p, then p into p minus 1, then p into p minus 1 and p minus 2, like that. But in backward difference, we use p, then p into p plus 1, there p minus 1, p plus 1, p plus 2, like that. And number of factors what we have multiplied in the numerator as 2 factors, here we write 2 factorial, this is delta square. Here 3 terms, so 3 factorial delta. Just this is the technique to remember. Okay, so this is the formula for the Newton's backward interpolation formula and derivation. Okay, you see the derivation is very simple. If you follow some other books, you will see very lengthy derivations, but I have derived this in a very simple manner with the use of shift operator. Okay, now let us work out the numericals. Now we will solve the numericals. Okay, you see, this is given. This is the set of data x and y, and you have to find the value of y at 11 and value of y at 9, right? When you will work out the problem, you are having 4 formulas: Lagrange, Newton's divided difference, Newton's forward, Newton's backward. Okay, you have to decide which formula you have to use. First you see the data of x, that is 2, 4, 6, 8, 10, 12. That means this is equispaced. When it is equispaced, you will apply either Newton's forward or Newton's backward. Then you come to the desired point. We will solve case 1. We will solve case 1. If we will solve case 1, this is our case 1, this is case 2. As we are solving case 1, where 11 lies between 10 to 12, means it is to the last part of the data. As it is to the last part of the data, we apply Newton's backward difference interpolation formula. Clear? So now find out which formula we will use. Then we start the solution process, because once we decide which formula we will use, accordingly we will make the table and formula. So make the table. This is x, this is x, and this is y. Okay, so x is 2, 4, 6, 8, 10, 12. Y is 5, 8, 13, 15, 28, 35. Then even if it is, we have decided that we have to work out by Newton's backward difference interpolation formula, still you have to make the forward difference table. That is important. You write delta. 8 minus 5, 3. 13 minus 5, 5. 15 minus 13, 2. 28 minus 15, 13. 35 minus 28. Okay. So this is our forward difference table, first order. Then you write the second order. 5 minus 3, 2. 2 minus 5, minus 3. 13 minus 2, 11. 7 minus 13, minus 6. Then you write delta q. Minus 3 minus 2, that is minus 5. 11 minus of minus 3, 14. Minus 6 minus 11, minus 17. Then you write delta 4. 14 minus of minus 5. Plus 5, that is 19. Minus 17, minus 14, that is minus 31. Then delta 5, minus 31, minus 19, that is minus 50. So this is our difference table, right? Mind it. It may be Newton's forward difference, it may be Newton's backward difference, but in every case you have to form the Newton's forward difference interpolation, right? Now we have to find out y11. To find y11, that means x is equal to 11. What is xn? You see, you have to find x is here, so after that is 12, so xn is 12. Okay, you have to find out ax is equal to xn plus ph, that means 12. Sorry, x is 11. 11 is equal to 12 plus p. What is h? H is the step length. 2, 4, 6, 8. Step length is 2. Implies p is equal to 11 minus 12 by 2. That is minus 1 by 2. That is minus 0.5. We calculate p. Now you apply the formula. That is y of x. That equal to, what is x? X is here 11, so that is y of 11, that equal to. Then the formula is yn. Okay, first let us write the formula, then we will put the values. Y of x is, after finding the value of p, now we will write the formula for x, that is y of x. Y of x is yn plus p backward delta yn plus, in Newton's forward we write p into p minus 1. Here you will write p into p plus 1. That is p into p plus 1 by 2 factorial backward delta square yn and so on. This is the formula. Now you put the values, implies y of what is x? X is 11, that is our desired point. That yn, this is our last data xn, corresponding to that is yn, means you will use this set of data, mind it. So when we use the Newton's backward interpolation, we formulate the forward difference table, but we use the data from the last. So that is yn is 35 plus p we have calculated, that is minus 0.5 into backward delta yn. This is backward forward, but we find backward delta, means last data, that is 7 plus. Then p into p plus 1 minus 0.5 into minus 0.5 plus 1 by 2 factorial, then this is backward delta yn, this is backward delta square, so delta square, that is minus 6. Okay, then plus, next term minus 0.5 into minus 0.5 plus 1 into minus 0.5 plus 2. We have written 3 terms, so in the denominator that is 3 factorial. In the denominator 3 factorial means you have to write backward delta q, that is minus 17 plus. Similarly, you write for this term, that is minus 0.5 into minus 0.5 plus 1 into minus 0.5 plus 2 into minus 0.5 plus 3. You have written 4 terms, then divided by 4 factorial. 4 factorial means you write the backward difference, that is minus 31 into minus 31. Okay, then another term, actually there is no, okay, you will write here plus. The last term is minus 0.5 into minus 0.5 plus 1 into minus 0.5 plus 2 into minus 0.5 plus 3 into minus 0.5 plus 4. We have written 1, 2, 3, 4, 5. Then divided by 5 factorial. Okay. So we have written 5 terms. Then here you have to write the 5th order backward difference, that is minus 50. Okay. So we have put all the related values in the formula. Then you calculate all these values starting from this 35 to this last term using the numerical calculators, and you will get the results. Okay. So this is all about the numericals where we apply Newton's backward difference interpolation formula.